This is Fan of Astronomy, episode 13, Jupiter, part 3. Hi guys, Dan here. I still don't have a fancy intro. I will try to get the fancy intro from Angelo. But I do have, I hope, a new co-host. And in March, there will be an episode with the new co-host. However, I don't want that new co-host to be forced to start with Jupiter Trojans and Jupiter spacecraft. So I figured I would talk about that today. I have also noticed that since we went off air with the podcast, it has become a lot more popular. That's interesting. So a lot of people have found the podcast. We now have some patrons. Thank you. A good way to ensure that this podcast actually comes out and continues, that I find a new co-host, is to become a patron at patreon.com/astronomy. There is a link in the show notes, and we probably need about $100 or so to make sure that this actually happens. But I do love astronomy, and I will not stop loving astronomy. So sometimes the inspiration just strikes me and I make an episode. But making this episode all by myself is not my intention. My bigger podcasts is all by myself, and I want to do these subjects like history and astronomy and English and stuff with people and not alone. But today I will finish the story of Jupiter. And I think there are two major things to talk about: the spacecrafts and the Trojans. So if you think I forgot something about Jupiter, let me know and we'll address it in a later episode with the new co-host. So there have been two different kind of spacecraft missions to Jupiter. First the flybys, and then spacecraft going actually into orbit. There is a slingshot effect at Jupiter. You can get close to Jupiter and then use the velocity to speed yourself up. Beginning in 1973, several spacecraft have performed planetary flyby maneuvers that brought them within observation range of Jupiter. And in 1973, we had Pioneer 10. In 1974, we had Pioneer 11. Pioneer 11 got extremely close to Jupiter, 34,000 kilometers. It's the closest any of these flyby missions ever got. So they got some close-up images of Jupiter and several of its moons. They discovered the radiation fields near the planet and how strong they were, much stronger than expected. But both Pioneer 10 and 11 managed to survive. And the trajectories of these spacecraft were used to refine the mass estimates of the Jovian system. So 6 years later then, things happen. In 1979, both Voyager 1 and Voyager 2 passed by Jupiter on March the 5th and July the 9th. And that vastly improved the understanding of the Galilean moons and also led to the discovery of Jupiter's rings. They also confirmed that the Great Red Spot was anticyclonic. Comparison of images showed that the red spot had changed hue since the Pioneer missions, turning from orange to dark brown. So, but not very much a change in size. And then we sent a solar probe, Ulysses. The Ulysses solar probe passed by Jupiter in 1992 and in 2004, but the 1992 flyby was a lot closer to Jupiter. Ulysses had no cameras. It couldn't take an image. Not so impressive. But in 2000, Cassini flew by Jupiter on its way to Saturn and provided some of the highest resolution images ever made of the planet. Then we got New Horizons. It passed by Jupiter in 2007. But then we have two other very interesting spacecraft. We have the Galileo mission. The first spacecraft to orbit Jupiter was the Galileo probe, which entered orbit on December 7th, 1995. It orbited Jupiter for over 7 years, conducting multiple flybys of all the Galilean moons and Amalthea. Remember Amalthea, the little moon that is very close to Jupiter. The spacecraft also witnessed the impact of comet Shoemaker-Levy 9. Okay, probably don't get away from talking about Shoemaker-Levy 9. I will talk about that too. So we had a great vantage point for the event from the Galileo probe and watched this enormous catastrophic thing that was Shoemaker-Levy 9 in 1994. Galileo had with it something. It brought a 340 kilogram titanium atmospheric probe that was released from Galileo in July 1995 and entered Jupiter's atmosphere in December 7th of the same year. Parachuted through 150 kilometers of Jupiter's atmosphere at a speed of about 2.6 kilometers an hour, and collected data for 57 minutes before it was crushed by the pressure of about 23 atmospheres at a temperature of 153 degrees centigrade. So the poor probe melted and vaporized. That also happened to Galileo itself when it was deliberately steered into the planet on September 21st, 2003 at a speed of over 50 kilometers per second to avoid any possibility of Galileo crashing into and possibly contaminating Europa, a moon which had been hypothesized to have the possibility of harboring life, as we talked about in the last episode. And then we sent Juno. Juno arrived at Jupiter on July 4th, 2016, and was going to do 37 orbits on 20 months. The mission plan called for Juno to study the planet in detail from a polar orbit, and we have some nice pictures from Juno. But Juno is still going, so we'll talk more about that when it's finished. There are some future probes planned to Jupiter as well. The next one is the European Space Agency's Jupiter Icy Moon Explorer, very cleverly called JUICE, due to launch in 2022, followed by NASA's Europa Clipper mission in 2025. The Europa Clipper mission is super interesting, and I hope we get to cover that on this podcast. Okay, let's ignore the Trojans. Let's talk about comet Shoemaker-Levy 9. We've long speculated that Jupiter is kind of like our big brother. It's protecting us from the evil rocks of the solar system and outer space, and maybe Jupiter is one of those rare things that make the rare Earth hypothesis so interesting. Maybe you need a big brother like Jupiter protecting yourself from the rocks. There are different ideas about this. Maybe Jupiter hurls rocks at us and it's actually dangerous. But the fact that Jupiter catches some stuff was proven very clearly in July 1994 with comet Shoemaker-Levy 9. Shoemaker-Levy 9 broke apart in July 1992 and collided with Jupiter in July 1994. Providing us with the first direct observation of an extraterrestrial collision of solar system objects. This was extremely popular in the media, so this was all over the news. The comet itself was then earlier discovered by astronomers Caroline and Eugene Shoemaker and David Levy, so Shoemaker-Levy 9, then the ninth thing they discovered. It had been captured by Jupiter and was orbiting the planet. They found it on the night of March 24, 1993, in a photograph taken through the Smith telescope. And then calculations showed that it was unusual. It had been torn apart by Jupiter, and one of its it had passed within the Roche limit of Jupiter, and Jupiter's tidal forces had pulled apart the comet. So there was a series of fragments ranging up to 2 kilometers in diameter. These fragments collided with Jupiter's southern hemisphere between July 16 and July 22, 1994, at a speed of approximately 60 kilometers per second. The prominent scars from the impacts were more easily visible than the Great Red Spot and persisted for many months. Every telescope was directed at Jupiter, and we didn't know if there would be an explosion or not. Like if the comet would just disappear into Jupiter, but boy, was there an explosion. It was kind of hidden from us, but instruments on Galileo detected a fireball that reached a peak temperature of about 24,000 degrees Kelvin, compared to the typical Jovian cloud top temperature of minus 140 degrees centigrade. And it expanded and cooled rapidly to about 1500 Kelvin after 40 seconds. The plume of the fireball quickly reached a height of 3,000 kilometers. And it was quite an explosion. The astronomers were looking at long-term effects of the Shoemaker-Levy 9 collision, and they could see ammonia and carbon disulfide in the atmosphere of Jupiter for at least 14 months after this. But then eventually Jupiter returned to normal, and Shoemaker-Levy 9 is not unique in crushing into Jupiter. There is very strong evidence that comets have previously been fragmented and collided with Jupiter and its satellites. During the Voyager missions, planetary scientists identified 13 crater chains on Callisto and 3 on Ganymede. Crater chains seen on the Moon often radiate from large craters and are thought to be caused by secondary impacts of the original ejecta, but the chains on the Jovian moons did not lead back to larger crater. The impact of Shoemaker-Levy 9 strongly implied that the chains were due to trains of disrupted cometary fragments crashing into the Jovian moons. And then we had an impact event on July 19, 2009, exactly 15 years on the day after Shoemaker-Levy 9. A new black spot about the size of the Pacific Ocean appeared in Jupiter's southern hemisphere. Thermal infrared measurements showed the impact site was warm, and spectroscopic analysis detected the production of excess hot ammonia and silica-rich dust. So another impact event had occurred, but this time a more compact and strong object, probably a small undiscovered asteroid, crashed into Jupiter. And now we got to talk about the Trojans of Jupiter. I think we talked about Lagrange points and Trojans before. Lagrange points are interesting points where gravity is zero. For an enormous planet such as Jupiter, there are huge Lagrange points. And we are especially interested in Lagrange point 4 because it's 60 degrees ahead of the planet in its orbit, and Lagrange point 5, which is 60 degrees behind. And these Lagrange points are huge. The Jupiter Trojans are asteroids caught in the Lagrange points. They are stable in their orbit. So the Trojans in L4, they orbit ahead of Jupiter and they always stay 60 degrees ahead. And the Trojans in Lagrange point 5 are 60 degrees behind Jupiter at all times. In 1906, the first Jupiter Trojan was discovered. It was 588 Achilles. In May 2017, 6,515 Jupiter Trojans have been discovered. And by convention, they are each named after a mythological figure from the Trojan War, hence the name Trojan. The total number of Jupiter Trojans larger than 1 kilometer in diameter is believed to be about 1 million, approximately equal to the number of asteroids larger than 1 kilometer in the asteroid belt. But these things are smaller. There are no big guys like the big asteroids. So a Jupiter Trojan is often dark with the reddish featureless spectra. We have not found any presence of water or any other specific compound on their surface, but they are thought to be coated in tholins, organic polymers formed by the sun's radiation, and density seems to be between 0.8 to 2.5, meaning that they are not really rock. So this term Trojan is used for anything that is stuck in Lagrange points, including Trojan moons of Saturn. There's also an Earth Trojan. I hope we talked about that in the Earth episode. Maybe it wasn't even discovered by that point. But there are some strange things with these Jupiter Trojans. There are just so many of them, so how did they end up there? And that might have something to do with the NIS model that we're going to talk about in a separate episode later. It is a model of how our solar system is formed, because at this point we know that the solar system is pretty weird. We have found a lot of extrasolar planets, and the extrasolar solar systems, they don't look anything like ours. So ours seems to be pretty strange, and the NIS model kind of explains what happened, how Planet 9 got thrown out so far out, how Neptune and that seventh planet got thrown out as well. But the theory then is that Jupiter picked up all these Trojans out of the asteroid belt. And it is interesting to note that we have, to this date, not found a single Trojan around Saturn. So we have millions of Trojans around Jupiter, but none at Saturn. And here's another theory, a revised version of the NIS model, when the Jupiter Trojans are captured by Jupiter when Jupiter encounters an ice giant during the instability. In this version of the NIS model, one of the ice giants, the seventh planet, Neptune, or a lost fifth planet, or Planet 9, is scattered inward onto Jupiter crossing orbit and is scattered outward by Jupiter, causing the orbits of Jupiter and Saturn to quickly separate. When Jupiter's semi-major axis jumps during these encounters, existing Jupiter Trojans can escape, and new objects with semi-major axis similar to Jupiter's new semi-major axis are captured. Following its last encounter, the ice giant can pass through one of the libration points and perturb their orbits, leaving this libration point depleted relative to the other. After the encounters end, some of the Jupiter Trojans are lost and others captured when Jupiter and Saturn are near weak mean motion resonances, such as the 3-7 resonance, via the mechanism of the original NIS model. The NIS model will have to come back to that, but that's a competing theory. I like the one where Jupiter steals all the asteroids. We are actually sending a spacecraft to the Trojans of Jupiter. It's named Lucy, and it will be sent by NASA. It is going to be sent in 2021 and will arrive at the L4 Trojan cloud in 2027 after a flyby of a main belt asteroid. It will return to the vicinity of Earth for gravity assist to take it to L5, the other Trojan cloud, where it will visit 617 Patroclus. Also, the Japanese Space Agency has proposed the Jupiter Trojan Asteroid Explorer for the late 2020s. So the Trojans of Jupiter are named after heroes in the Trojan War. But there are two asteroids that were named before this happened. And it's 617 Patroclus and 624 Hector. And they are in the wrong camps. Patroclus is a Greek hero in the Trojan War, but he is in the Trojan camp as a spy. And Hector himself, the leader of the Trojan camp, is in the Greek camp, which is kind of strange. So L4, the camp that is 60 degrees ahead of Jupiter's orbit, is the Greek camp, and L5 is the Trojan camp. I hope I said that. So let's take a look at one of these guys. It's 588 Achilles. It's the sixth largest Trojan. It has a diameter of 135 kilometers. And it shares a lot of its attributes with Jupiter. It orbits at the same distance from the Sun. It takes about the same time to go around the Sun, of course. It rotates around itself in 7.32 hours. The albedo is really small, between 0.033 and 0.043. The 5 Trojans that are bigger than Achilles are 624 Hector at 225 kilometers, and that's the biggest one. 911 Agamemnon, 1437 Diomedes, 1172 Aeneas, and 617 Patroclus that we talked about. I need to say one more thing about Patroclus. Patroclus is a binary system that's super interesting, right? It's made up of 2 components with a minor planet moon of roughly similar size. And they found 18 binary Trojan asteroids. That's fairly interesting. And they orbit each other with 680 kilometers between them. That's not far. What a strange thing. That's all I have today. And I hope I'll be back in March with a new co-host. That could still fail. We're all doing things on enthusiasm here because we have no money. If you want us to have money, go to patreon.com/astronomy. Okay, I should stop begging now, but I really want this podcast to live again. Thank you for listening.